Hello, my Algebra 2 students. I'm actually in the math office right now while I'm doing this, so in case you hear any random voices, might be another math teacher wandering around in here. We are doing inverse of linear functions. So the nice thing is we've talked about inverses already, so this will feel like a little bit of review, but then just specifically focusing on when you have a linear function or just the fact that if it's a linear function, you're just looking at lines. So when it says recall that functions have inverses, if they are 1 to 1. All right, of course, with the exception of horizontal lines, because that would be a special little case there. We can talk about that more tomorrow. Um, so you've got an example already drawn out here for you. You've got y equals 2x minus 4. So that's this line on the graph. And then the line y equals x. So I'm just going to highlight over that line just to distinguish it from the line we're working with. And it says, how can you tell that the line y equals 2x minus 4 is 1 to 1? If you remember the check, to be a function, it has to pass the vertical line test. But to be 1 to 1, it needs to pass the horizontal line test as well. And this one would. It would only hit once this way or this way. All right, graph the inverse. So I'd recall this is easily done by just switching x and y coordinates of the original line. So I'm just going to take a couple of points here. So if I take right here, that's the point 2, 0. And I switch the x and y, that'll now be 0, 2. So if we go plot 0, 2, that guy's moving over here. I can use this point at 1, negative 2, and flip-flop it. It'll be negative 2, 1. And then let's go one more. If we take this one, this would be 0, negative 1, 2, 3, 4. So 0, negative 4. That's going to go to negative 4, 0. All right, that's enough to give us a line here. If you have a straight edge nearby, take advantage. All right, so there's our inverse function. So when it says what can be said about the graphs of y equals 2x minus 4 and the inverse with respect to the line y equals x, here's your geometry brain right here. It's symmetrical over the line y equals x, which means it's a reflection over the line y equals x. All right, so if your x and y points flip-flop, you are going to have a reflection over that line. All right, finding the actual equation. We know how to do this. So go back to the original. So 2x minus 4, and let's switch the x and y. So x is over here, y is over here. Just start moving some things around to resolve for that y. So if we add that 4 on over and divide by 2, we're going to end up with x plus 4 over 2. Or because the equation says, or excuse me, the question says write it in y equals mx plus b form. Remember, that just means we're dividing this by 2 and dividing this by 2. So there's that nice little 1 in front of that x if we don't see it. So bring that 2 underneath there. So we'd have 1/2 x, and then 4 over 2 would just be plain old 2. So there's our mx plus b form, which means here's our y-intercept. Here's our slope. And if we go back and look at that picture, the y-intercept, it's crossing right there at 2, the slope of 1/2. So up 1 over 2, up 1 over 2. It's nice and easy to see there. When it says find the equation of the inverse in y equals x plus b, over, right? That would have just been if we had left it back here. So it's not incorrect if we leave it in that format, just it's easier for us to understand how it will look when we get it all the way into that y equals mx plus b form. Right. Flip it on over to page 11. We're going to do just one of these together here. So saying for each of them, can we graph it? Graph the line we're going to flip on over, graph the inverse, and then write the equation. So start with graphing that linear function. So remember the basics. So we've got our slope and our y-intercept. So starting at that y-intercept of -7, and then counting out a slope, it'll be up 5 over 1. So it's going to be pretty steep. All right, so count it out maybe a couple times because otherwise that line starts to go a little off kilter if we don't plot enough points. All right, so here's our original, and let's label it. So y equals 5x minus 7. All right, graph the line y equals x. So that's that perfect diagonal that passes right through the origin. Because if you think about it in terms of y equals mx plus b, it's starting at 0, and then you're counting out that slope of up 1, right 1, up 1, right 1. So I'm going to graph it, but then I'm going to highlight it as well, just like we did on the first page. So if you have a highlighter sitting close by, it's good to mark it. All right. Graph the inverse. You choose. You can rearrange the equation first and then graph it, or you could just pick a couple of pretty points that are on the line and graph those first. So I'm going to grab a couple of nice points here. So I know the y-intercept is at 0, -7. So that's going to go to -7, 0. And then let's see here, we are at 1, -2. So that's going to go to -2, 1. And I'll grab one more. This is the point 2, 3. So I know that's going to flip-flop and go to 3, 2. There we go. All right, we got to label it with the equation. So let's do that last. So taking the original, we are switching that x and that y. Oops, hold on there. All right. So flip-flop it. We get x on the left, 5y minus 7 on the right. Start moving things around. So let's add that 7 to the other side. Divide everything by 5. So we can leave the equation as x plus 7 over 5. Or if we want to go into slope-intercept form, then it would be 1/5 x plus 7/5. This is not that easy to plot because 7/5, if I look, it's a little more than 1. That is where it crosses, but it's not easy to graph it this way. It's actually a little simpler to find a couple points and plot those. But hopefully it makes sense when we see the matchup there. All right, save number 2. We'll do that one in class. And then we're going to skip number 3 as well. Let's do one more on the next page, on page 12. I like these ones because it's saying sometimes we're asked to work with linear functions in point slope form. So from geometry last year, that's when it's y minus y1 equals m times x minus x1, where m is still the slope, and then you're using any point x1, y1 that you know is on the line. It doesn't have to be the y-intercept itself. That's where that equation came from. So if we jump down to example 5, let's let that be the last one that we do together. When it says, which of the following points lies on the graph of the inverse, and explain your choice. What I really want you to think of is how can you deconstruct this to figure out what point was plugged in to create the equation. So when we line this up with y minus y1 equals m times x minus x1, the slope is 5, but the point is this 2 and this 8 over here. What you have to remember is that because the equation is built with negatives, the sign is the opposite of how it looks. So if it's x plus 2, that's really a -2. And if this is a minus 8, that's really a positive 8. So here's the x and the y coordinate, that was being plugged in. All right, so that's the point on the line. So now when it says, which of the following points lies on the graph of the inverse? All right, now we got to switch the x and y. So if we flip-flop those, we would have positive 8, -2, and we're looking at choice 1 right there. So when it says explain, hopefully this is enough of an explanation over here. But we'll come back and we'll do some more of these practice ones tomorrow in class. Thanks, guys.